Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about 805 schematic pinout. That is a pin diagram of 8051 microcontrollers. Look at this schematic of pinout. Actually this is a 40 pin ICs. Look at this. Pin number 20 is connected to ground. Pin number 40 is connected to supply voltage VCC. That is a 5 voltage. Look at these ports. So P0.0 to P0.7, totally we have an 8 bits, so port 0 pins. So it consists of IO function, that is an input output function, and address lines and data lines. So look at this, pin number 39 to, that is 32 to 39. So AD0 to AD7, that is an address line A0 to A7 and data line D0 to D7 and IO lines P0.0 to P0.7. All three are multiplexed with this port 0. It can perform an IO operation, it can perform as an address bus and it can perform as a data bus. How it will be multiplexed or decoded? So that by using this control signals. So address and data will be decoded with an ALE signal, that is address latch enabled signals. So whenever you use an IO operation, that IO lines will be decoded. Look at this port 1, port 1.0 to port 1.7, pin number 1 to 8. Here there is no signal will be multiplexed. So only it have an IO function, that is an input or output function. Look at this port 2 pins, port 2.0 to port 2.7, it have a signals from an A8 to A15, that is an address bus A8 to, that is here A0 to A7 lower 8 bit, here higher 8 bit A8 to A15. So totally 16 address lines, that is comes from A0 to A15. Lower 8 bit will be multiplexed with the port 0 and higher 8 bit will be multiplexed with the port 2. Look at this A8 to A7. So this address bus and IO lines will be multiplexed. Look at this port 3, port 3.0 to port 3.7, pin number 10 to 17. So these signals as an IO lines also it will be multiplexed with the control signals. So read signal, write signal, timer 1, timer 0, interrupt 1, TXT line, RXT line. So these are the individual lines that will be connected with this port 3. So we have an alternate input output lines will be connected with these lines because we need to have the control signals also. So to reduce the chip size only we are using this multiplexing concept. And other control signals like a reset, this is a pin number 9. External enable, so this will be used for an external memory or internal memory. This is for pin number 31. This is the address latch enable. Program stop enable, this is the pin number 29. And crystal, this is an oscillator for a clock pulses. Pin number 18 and 18 will be connected with crystal with this capacitor. So this capacitor will be used for a clipping that sine waveform and that will be given to as a clock pulse for the circuits. Look at the schematic, the same pin diagram. So here we have combined with the functions. Here we are combined with the pin numbers. Look at this. So from pin number 1 to 40 that will be mapped with this. So this is the pin number 1, 2, 3, 4, it goes up to pin number 20 and then from pin number 21 it goes to up to pin number 40s. The same function how it will be mapped exactly this will be shown here. So pin number 0 to 7 that will be mapped with the P1.0 to P1.7 and this pin number 8 and then pin number 9 to next 8 lines that will be mapped with the P3.0 to 7 and also with the multiplexing signals and then crystal connections, this is pin number 18 and 19, pin number 20 that will be connected to the grounds. Look at this side P2.0 to P2.7, pin number 21 to 27 that will be multiplexed. Next 3 lines there is a program stop enable and then ALE signal and external access. So this will be mapped. Higher pin number 40 is mapped with this VCC. Pin number 39 from this 32 it will be mapped with this pin that is port 0.7 line to that is port 0.0 line. It is also multiplexed with AD0 0 to AD7, that is address A0 to A7 and data bus D0 to D7. The same function, this is the schematic with the actual pin numbers. The important pins for an IO ports, so port 0, pin number 32 to 39, it is act as a port 0.0 to port 0.7. So it will be have an 8-bit read write general purpose IOs or it can act as a lower bit address, also it can act as a data bus. If you take a port 1, it have only the IO lines. Only it act as a general purpose read-write logics. Port 2, it have this read-write that general purpose IOs and higher 8-bit addresses. Port 3, it have a general purpose IOs and we have a special functions like a timer, external interrupt and serial ports, all the things that will be multiplexed with this port 3. Thank you.